The purpose of this video is to understand how to write formulas of ionic compounds. This is sort of an introduction to ionic compounds. You should already know a little bit about ionic bonding and periodic trends. And if you don't know those things, you should go back and watch those videos. But let's start out real fast with the periodic table and a few basic trends that you should know. First of all, remember, everything in group 1 tends to lose electrons. They tend to lose one electron, so they will have a +1 charge because they have more protons than electrons, which we've gone over before. Everything in group 2 tends to lose 2 electrons, so they will normally have a +2 charge. In group 3 or 13, it's +3. Now if we go over to this side of basically nonmetals, they're mostly gases over here, these tend to gain electrons. So the halogens in group 7 right here tend to have a -1 charge, chalcogens -2, and over here -3. So basically, yet again, everything over here will lose electrons and these will gain. So these will form cations. Cations are simply atoms that lose electrons and have a positive charge. These will form anions, which gain electrons and have a negative charge. Cations and anions will bond together through an electrostatic force to make ionic compounds. Now these transition metals in here tend to have various oxidation states, which we'll talk about. So for instance, copper. Copper might lose 1 electron, but it might lose 2, depending on what it bonds with, or 3. So everything in here can vary, and that's going to be a difficulty when we talk about how to write out these formulas. Let's go check out our sheet. Here we have a basic sort of little chart that you would fill out in class. Right here we have cations. Here we have anions. Notice these are all negative, they're anions, and these are all positive. So let's start on this really fast. Right here we have a sodium cation. And naming these cations is very easy. It's the name of the element and cation. So this is a sodium cation, potassium cation, zinc cation. Naming these is a little bit more difficult. Normally you drop the ending. So this is chlorine. We drop the ine and we add ide. That's how you know it's an anion. So this is chloride. Chloride is not the same thing as chlorine. Chloride has 1 more electron. It's different. And we'll get into these in a moment. So basically, we have a sodium cation and a chloride anion. This means it has a -1 charge. This has a +1 charge. People say -2 or 2-. They normally say 2-, 3-. I notice this chart is a little bit backwards, but in the end you get the rough idea. It doesn't really matter that much. So these charges have to equal out when they combine together. We will have 1 sodium cation combined with 1 chloride anion, NaCl. The ionic compound that is formed has to be neutral. See how there's no charge here? This is a neutral ionic compound. So that's something to keep in mind. Let's go check out some more here. Potassium. It's also a +1. And this is a +1 potassium chloride. Okay, that seems easy enough. Well, let's go down. This is a little bit harder here. We have a zinc cation, it's +2, and we have a chloride anion, -1. Well, what do we do there? Well, when in doubt, write it out. Oops, we're on zinc. We have zinc +2. Chloride -1. Well, what if another chloride ion was around, and then these 2 chloride ions would equal -2, and that would cancel out the +2 here. And that's exactly what happens. But how do we write that? Well, we only have 1 zinc cation, but now we have 2 chlorides. We just put Cl and put a little subscript down here, 2. That tells us what's going on. Yet again, that seems moderately straightforward. And now I know if I ever have a plus 2 here and a minus 1, I could just do the same thing. So here's calcium, 1 calcium. I'm going to need 2 chlorides. I'll add that in. We have magnesium, 2 chlorides. This goes pretty fast once you figure that out. Wait a minute. This is an iron plus 3. It's an iron cation with a 3 charge. So it's an iron atom that has lost 3 electrons. Well, I could have 1 chloride come in. That's not going to work. I could have another chloride come in. That's only going to be minus 1 plus minus 1 is minus 2. Let's have a third one come in. Minus 1, minus 1, minus 1 is minus 3. So in that case, I have to write FeCl3. Well, this is an aluminum, so that's the same thing, aluminum, Cl3. Now let's go up here and check this out. What in the world is this? Whenever students look at that, they're like, what is that? Well, this is a polyatomic cation. So if I go to my list right here, I can see that I have a list of common polyatomic ions. Poly means many, atomic means atoms. These are many atoms bonded together. Most of these are covalently bonded, but they have a charge on them, so they're units. The whole thing together has a charge. Let's check this out. NH4, that's one of the few that are positive. It's a cation. So it's ammonium, NH4 plus 1. Let's go down to our chart. Well, I don't need to know the name. I know this whole thing has a plus 1. This has a minus 1, so I guess I can just write NH4, ammonium. Cancels out the chloride. Okay, let's go on over here. This gets a little bit harder. Remember how I just said there's polyatomic ions you have to memorize? That's what all these are. CO3 minus 2. What is that? Yet again, go back to the handy dandy chart. CO3, 2 minus, is carbonate. Go back down. Yet again, I don't really need to know the name, but I know it has a minus 2 charge. So now what do? Well, I just reverse that. I'm going to need 2 sodiums. So that's going to be plus 2 together, and then 1 carbonate. Sodium carbonate. This is called hydroxide. It has a minus 1 charge. This is a plus 1, so I just put down NaOH, sodium hydroxide. Well, and yet again, as I see in this chart, if it all has, this is minus 1, that's plus 1. Anytime it does that, I can just write down the formula very fast. Potassium hydroxide. And then, if I have more than 1, this is a plus 2, I'm going to have 2 of these. So how do I write that out? Well, I have 1 calcium cation. Here's the thing. If I have 2 of these, I have to write it like this. Parentheses, OH, 2. I have to have the parentheses there because it tells me I have 2 hydroxides. If I don't have the parentheses, someone might think this is a completely different thing where there's 2 hydrogens bonded together here, which isn't true. So that's why I have to put these parentheses in here so people know specifically what we're talking about. Right here, I'm sort of in the same situation. I have magnesium cation, OH, 2. Zinc cation, OH, 2. Iron cation, OH. Hi, you thought I was going to get confused, didn't you? But that's going to be an OH, 3. Aluminum, OH, 3. Well, that seems easy. Let's go over here. Let's look at something a little bit harder here. Well, this is called nitrate. This is phosphate. This is sulfate. Yet again, if you don't know it, you got to go look it up on this little chart. I really advise you to have this chart handy near you, or a chart like this when you're doing this, because just familiarize yourself with this. The more you look at it, the better you're going to get. So this is sodium. This is still a minus 1 charge here. So I have a sodium, nitrate. Okay, this I have a sodium phosphate. But let's go down to something slightly harder. Let's go down to calcium and phosphate. This is going to get confusing. First of all, I have a calcium here, plus 2, but I also have a phosphate, which is minus 3. I can't just bond these two together. I can't just put these two together because I'll still have like a minus 1 charge. You can see that these charges won't cancel out. It will not make it neutral. This is where people get confused. They start thinking I need to mess with this number here. Do not mess with these numbers by the oxygens or these other little numbers here. This number tells me this is phosphate. I can't change that. All I can do is add more of these. Well, what if we add another calcium? Notice I'm writing it out. When in doubt, write it out. So if I have another calcium come in, well, that's going to be plus 4. That's not going to work. Well, what if I add another phosphate and have that come in? It wants to be friends. Well, that's going to be minus 3, minus 3. It's minus 6. Wait a minute. I'll have another calcium come in. So now I have plus 2, 2, 2. That's plus 6. This is minus 3, minus. That's minus 6. Well, how do I write this mess? That's probably what you're thinking. Well, we write the cation first. We got 3 of them. So we'll put Ca3. Now we got to have the parentheses because this is phosphate, PO4. Can't change that. All we can change is how many of them that we have. Well, we have 1, 2. 2. Now this is where something comes in that's called the crisscross method. I didn't want to tell you about it at first because if you learn it first, sometimes you get confused about what's really going on. But this is how the crisscross method works. I write out my cation, Ca plus 2. I write out my anion. This is my polyatomic anion. I write out my charges. Now these charges just crisscross. I take the 3. It's not a charge anymore. It's just a subscript. I put it here. I take this 2 and I put it here. And notice that's what I have. I have a 3 and a 2. I didn't change this 4. That's where people get confused. They think this 2 has to go down here. It combines. They have to subtract, divide, or something. No, I just go straight down and put the 2 right here in parentheses. Now, the only thing you got to watch for is if these tend to be multiples, let's say this was 2 and this was 4, you have to reduce them to the lowest common multiple. So, well, that seems to make sense. This isn't as hard as we thought at first, right? Once we start figuring out what to do. Let's go down here and look at another one, zinc. Well, yet again, when in doubt, I got a zinc plus 2, phosphate, PO4 minus 3. If another zinc comes in, plus 2, that's only plus 4. Yet again, not going to work. Now I got 3 of them, 2, 4, 6. And yet again, just like the other one, or I could do the crisscross method. Zinc plus 2, phosphate minus 3. Yet again, the 3 goes here, the 2 goes there. So I have zinc 3, phosphate 2. Once you can do that, you pretty much already can do this entire chart. So that's a real basic introduction. We're going to do more activities with it because we still have to be able to look at the formula and write out the name and look at a name and write out the formula. This is just trying to introduce us to the crisscross method and how you write ionic compounds. Let's go back here to the crisscross method though. This shows us the crisscross method. Now right here, this is a Roman numeral that tells us this is lead 4. That's because if you remember right, these transition metals here, these have multiple oxidation states, meaning you could have lead 1, 2, 3, 4. So when that happens, they put a Roman numeral next to it so we know what it is. Oops. Let's get to the right. If I can get to the right chart. So that just tells me it's a plus 4. Sulfide, well, if I look at the chart, sulfur sulfide minus 2. So that's a minus 2. I put down my charges, and notice how they do the crisscross method. So they end up with Pb2S4, but yet again, I need the lowest common multiple. So I know 2 goes in there once, 2 goes in there twice, and if it's a 1, I don't really write out the subscript. Everyone just knows it's a 1. So that's how you get PbS2 with the subscripts and the crisscross method. Now we're going to go over this whole Roman numeral thing a lot more in some future videos. So don't worry about that right now. Let's just get started with this and make sure we understand the whole idea. And another thing you need to do is get started with memorizing these. You don't necessarily need to know all of these, but for instance, nitrite, nitrate, sulfite, sulfate, phosphite, phosphate, these you need to know. And notice that it all basically is named on how many oxygens they have. So if an ite has one less oxygen than an 8, but they have the same charges. So if I know phosphate is minus 3 or 3 minus, I automatically know a phosphite is going to be a PO3 3 minus. If I know sulfate is SO3 2 minus, SO4 2 minus, I know sulfite is SO3 2 minus. I just take away an oxygen. So we'll do some more work with that. But I hope that helps you understand the basics of cations, anions, how they combine together to form ionic compounds, and a basic idea of what polyatomic ions are. So keep practicing and hopefully good things will happen.